All right, so section 11.9 is solving probability problems using combinations. So, guys, the difference between 11.7, 11.8, and 11.9, 11.7 and 11.8 were just doing the counting principles, whether we were using permutations or combinations. 11.9 are probability problems. So the one thing I want us to remember is that the probability of an event, whatever that's going to be, is always going to be a number between 0 and 1, okay? So it'll be something like 0.62 or 1/3 or 7/19, something like that. It won't be a number bigger than 1, okay? It won't be a negative number. So it's going to be a number somewhere between 0 and 1. So let's go ahead and go through the first problem here and see if we can't figure it out. It says a club consists of 4 men and 5 women. Okay, so guys, it says 3 members are going to be selected at random to form a committee. What's the probability that the committee will consist of 3 women? Okay, so let's do this. The first thing I'm going to figure out is the total. If there's 4 men and 5 women, that means that there's a total of 9 people. Okay, so when I'm going to do my probability, the bottom part is the part I'm going to do first. We're going to choose 3 members, okay? So out of the 9, we're going to choose 3. And the question is, what's the probability that the committee will consist of 3 women? Okay, so we know that we have a total of 5 women, and we want to choose all 3 of them from those 5, okay? So I'm going to go ahead and do this on my calculator. I'm going to try one method first, guys, see if this works. Okay, so first thing I'm going to do, let me turn it on, clear that out. Okay, so I'm going to try typing it in exactly as I see it here. So I'm going to go 5, math, combination 3, okay, close my parenthesis, divided by parenthesis again, 9 math, combination 3, close that up, okay, hit enter. Okay, so if you notice I get a decimal, the reason why I'm going to try to convert this to a fraction is simply for the reason that when you're doing this in my math lab, it'll ask you to write it as a fraction. So if you notice, I hit the button that said math. The first thing that came up was this little fraction button here. I'm going to hit enter. I'm going to see if it's going to do it for me. It did. Okay, so all it did for me here was it converted my answer, which was a decimal, that 0.119047 business. It converted that to a fraction for me. So let me write this as 5 over 42. Okay. If it doesn't do that, guys, then what I have to do is I have to simplify my fraction. Okay, so I'm going to try to keep using that button as much as I can and see if it'll help me with the rest of these. Okay. So let's take a look at the next problem here. And it says, a flush in the game of poker is 5 cards of the same unit. So either 5 hearts, 5 diamonds, 5 clubs, or 5 spades. If you're dealt a 5-card hand, determine the probability that you'll be dealt a heart flush. Okay, so remember, the total number of cards that we have is 52. Okay, so my denominator is going to be 52. We're going to choose 5. Okay. Now it says we're dealt a 5-card hand. Determine the probability that we're going to get all hearts. So if you remember, there's 13 hearts, right? And we want to choose all 5 of those. So I'm going to do this the same way I did the other one. Grab my calculator again. So I'm going to go parentheses, 13, choose 5, divided by, parentheses, let's go 52, math, choose 5, close that up. Oops, I didn't do that right. Go delete, delete, delete it again. Oops, there we go. Okay, insert, math, probability. There we go. And we're choosing, what, 5 again? There we go. Okay, I think we should be good there. Okay, so I get, again, this rowdy decimal. Let me see if it'll convert it to a fraction for me. Enter. Okay, it's not going to convert it to a fraction for me. That's okay. So let's do it this way. 13 choose 5. Okay, so that's 1287. That's the number I have on top. And then, this is going to be a pretty big number, I'm pretty sure. So let's go second. This is a little way you can kind of get to your answer kind of quickly. I'm going to insert 52, and I'm going to delete 13. Okay, there we go. Whoa, buddy. So we got 259, 8960, 259, 8960. All right. Okay. So now the thing is here, I got to figure out how can I reduce this fraction. So, okay, guys, give me 1 second. Let me pull something up real quick like. Okay, so all I did here is pull up a basic multiplication table, right? And I want to see if there's anything I can do with this. So let me come back to my notes here. Okay, 1287. So guys, the reason I'm pulling this up, I end in a 7. So I want you to notice if I look at my 2's, well, if it's even, I have to be able to divide it by a 2, 4, 6, 8, 10, right? That's how I know my numbers are divisible by 2. So when I look at this first number here, 1287, I know I can't go by 2. So the next number I'm going to try is 3. So let's go 1287 divided by 3. Yes, that's working, 429. Now it doesn't mean the other one's going to work, but I'm going to try. Okay, so I'm going to go 429. 429. And let's see. What was the other number? 2, 5, 9, 8, 9, 6, 0. Let's see if we can divide it by 3. Whoa, buddy, we can. So 866, 320. 866, 320. Okay. I'm going to try dividing both of them by 3 again. So let me try dividing that bottom number by 3, see if that's going to work. No, it doesn't. Okay. So dividing it by 3 did not work. If 3 doesn't work, let me try 7. 7 worked. Okay. But I don't think 429 can be divided by 7. So I'm going to go like this, 429 divided by 7. No, it doesn't. Okay. So, can I divide 866, 320? Can I divide it by 11? No. Okay. I'm just trying to mess around here, guys, see what I can divide it by, see if I can reduce it any further. I can divide it by 13, 429. Can we divide that one by 13? Maybe, maybe not. Yes, we can. Wow, check that out. So now we have 33 over, what was the other one? 66640. 66640. And so now I'm going to stop right here. The reason I'm going to stop right here, we had already tried dividing them by both of them by 3 again, and it didn't work. And we already tried dividing them by 11, and that didn't work. And I want you to notice that 33, the only factors of 33 are 3 and 11, so that has to be my final answer right there, okay? So guys, what I want you to notice what I'm doing here, I'm trying to divide by my prime numbers, 2, 3, 5, 7, 11, 13, 17, 19, so on and so forth, okay? So I'm not going down every single number. If 2 doesn't work, I'm not going to try 4. Why? 2 doesn't work, neither will 4, okay? Okay, let's try the next problem here. Jennifer has 4 Scooby-Doo DVDs, 5 Magical School Bus DVDs, and 3 Bob the Builder DVDs. If Jennifer randomly selects 4 DVDs for her children to take on a trip, determine the probability that A, no Scooby-Doo DVDs are selected. All right, let's do A, and then we'll figure out parts B and C. Okay, so first thing I want to do, we have 4 Scooby-Doos, 5 Magic Bus, 3 Bob the Builder. So 4 plus 5 plus 3, 4 and 5 is 9, 9 and 3, we have a total of 12. Okay? And we're going to select 4 of them. So for part A, my denominator is going to be 12, choose 4. Okay? So now, when I look at the next piece, part A says we don't want any Scooby-Doo DVDs selected. So when I choose, I don't want to choose from those 4. I only want to choose from the Magic Bus and the Bob Builder. So that's going to be a total of 8, choose 4. Okay. So I'm going to do this again on my calculator. I'm going to try doing how I did it again the first time. I'm going to go 8, math, probability. I'm going to choose 4 of them. Divided by 12, math. I'll go back to my probability button. I'm going to choose 4 of them again. Okay. Again, I know I'm going to get a decimal. I'm going to see if this will convert it to a fraction for me. Yes, it does. So it looks like sometimes it'll work, sometimes it won't. You're going to have to play around with your calculator, guys, to see. Let's go with this, 14 over 99. If your calculator will work or if it won't. Okay. Now, I want you to notice part B. Part B says at least 1 Scooby-Doo DVD is selected. So let's think about what does at least 1 mean. It means we could have 1, or we could have 2, or we could have 3, or we could have 4. Okay, we're not going to have more than 4 because we're only selecting 4 DVDs. If you remember from previous sections, the way we can find the probability of at least 1, so the probability of at least 1 is equal to 1 minus the probability that we have none of them. Well, we just found the probability that we have none of them. So let's do this. 1 minus 14 over 99. I'm going to write this as 2 fractions, guys. I'm going to think of that 1 as 99 over 99, right? I got 99 problems, and probability is one of them. So my denominator here is going to be 99. So 99 minus 14 should be something like 85 over 99, right? Okay. And there is a part C. So let's do part C. So part C says we want 2 Scooby-Doo and 2 Magic Bus. Okay. My denominator is not going to change. It's still going to be 12 choose 4 because we still have 12 DVDs to choose from. All right, so we're going to look at now how many Scooby-Doo DVDs do we have? We have 4 of them. And we want to choose 2. Okay. And how many Magic Bus DVDs do we have? We have 5 of them. And we're going to choose 2, okay? Because we want 2 Scooby-Doo and 2 Magic Bus, okay? So let me see if I can do this exactly the same way on my calculator as I did before, okay? So let me move this over here. So I'm going to go parentheses, 4, math, probability. I'm going to choose 2 of them, okay, times 5, math, probability. I'm going to choose 2 of those, divided by, parentheses again, 12, math, probability, choose a total of 4, okay. Enter. And again, I'm going to go one more time, guys. Math to get my fraction button. There we go. And here's my answer, 4 out of 33. So there is my answer for 2 probability DVD or 2 Scooby-Doo DVDs and 2 Magic Bus. Okay. All right, let's go on to the 4th problem here. It says Connor's rare collection is made up of 8 silver dollars, 7 quarters, 5 dimes. Connor plans to sell 8 of his 20 coins to finance part of his college education. If he selects the coins at random, What's the probability that three silver dollars, two quarters, and three dimes are selected? Okay, let's do the first part. Let's find our total. Okay, so total number of coins, 8 and 7 is 15, and another 5 is 20, right? And it actually already told me that right there. And he's going to sell 8 of them. Okay, so first thing I'm going to do, guys, I'm going to do my denominator. 20, choose 8. Okay, now when I do the second piece here, let's go with this color here. Okay, we're going to pick 3 silver dollars, 2 quarters, and 3 dimes. So I want you to notice we have 8 silver dollars. We're going to choose 3 of them. We have 7 quarters. We're going to choose 2 of them. We have 5 dimes. We're going to choose 3 of those, okay? So again, just to let you know how I'm going to do this on my calculator, it's going to be like that, right? Okay, so let me see if I can do it this way. Let me move this over a little bit like that. Bring up the calculator. Move it over here. Okay, so let's do it. 8, math, probability, choose 3, close it off, times 7, math, probability, choose 2, okay, times 5, math, probability, choose 3, divided by a total of 20 coins, math, choose 8. Enter. Let's see if this will do it for me. Hopefully, hopefully, hopefully. Ah, so lucky today. 392 over 41.99. And we're all good, right? Excellent. Okay. So I'm hoping that you guys are starting to see a pattern on how I'm doing these problems, right? I think the hardest part, honestly, guys, is if your calculator does not reduce, okay? So maybe we'll come up with one like that. So far, my calculator is reducing, but again, we did one actually where it didn't, and it just took us a little time, but we were able to figure it out. Okay, so determine the probability of dealt 3 kings from a standard deck of 52 cards when 3 kings are dealt. Okay, so again, we're dealing with a deck of cards. We notice we have a total of 52. My denominator is going to be 52, choose 3. So now we want to pick 3 kings. Well, how many kings are there? There's only 4 of them. Okay. So let's try this again. Let's go 4, math, probability, choose 3, divided by 52, math, probability, choose 3, and close that off, hit enter. Let's see if it does it. Ah, it did not. Okay, so I'll tell you what, let's do 4, choose 3. Okay, 4, choose 3, easy enough, right? It's 4. Okay, so I'm going to type in the same thing again. I'm going to go insert 52. Let's delete the number 4. Enter. Okay, 22,100. This should be easy enough. I bet you we can divide them both by 4, can't we? Divide it by 4. Boom, 55.25. So now if I divide them both by 4, that is 55.25. 4 divided by 4, nice and easy is 1, right? Okay, selecting soda. Let's see if we can do this. So refrigerator has 3 cans of diet soda, 10 cans of regular soda. So again, I know my total is 13. We're going to choose 2 cans. Okay, so my denominator is 13, choose 2. It says determine the probability that both of them are diet. So how many are diet? 3. So 3, choose 2. Okay. So let's try this again. So 3, math, probability, choose 2. So guys, as I'm going through this, I'm hoping that, again, you're seeing sort of a pattern here on how to do these problems that, I think at first initially we'd think of something like this and it's like, wow, this seems pretty tough. But then as we go through it, it becomes a little easier to see. So here we go, 1 out of 26. Remember we said about probabilities, guys, they're all going to be either like decimals or fractions. They're not going to be any numbers bigger than 1, right? Okie dokie. Flu vaccine. Doctor has 5 doses. So we got a total of 5. There are 5 doses, right? We have 6 women, 8 men. So there's that's my total, right? So 6 and 8 is going to be 14 people, right? If the names of 5 of these people are selected at random, determine the probability that 5 men's names, are selected. Okay, so my denominator is going to be 14, choose 5. And they're saying, what's the probability that all vaccines are going to be given to the men? Well, how many men are there? There are 8 of them. Okay, so let's try this another time. 8, math, choose. 8, math, choose 5. Divided by 14, math, there we go. Choose, what do we say, 5, right? Okay, enter, math, give me the answer as a fraction value. There you go, 4 out of 143. Okay, and let's see. Okay, we got a few more to do here. Let's knock them out. Gift certificates. It says the sales department has 3 people. Manufacturing has 6, and accounting has 2. So 3, 6, and 2. 3 plus 6 plus 2 is 11. 3 people will be given a gift certificate. Okay, so I already know my denominator is going to be 11, choose 3. Okay, look what it says. Determine the probability that 2 will be from the manufacturing department. Okay, so the manufacturing department tells me right here, the manufacturing department has 6 people. And we want 2 of them coming from manufacturing. So we're going to say 6, choose 2. And one of those persons will be from accounting. The accounting has 2 people. So 2, choose 1. Okay. So again, just to give you a little reminder on my calculator, this is how everything is going to be set up, right? So let's move this over this way. Let's go math, 6. Choose 2 times 2, math, choose 1, divided by 11, math, choose 3, and math and fraction, and enter. There we go. Awesome. 2 out of 11. Okay. All right. Kings and queens. You're dealt 5 cards from the standard deck of 52. Determine the probability that you are dealt 3 kings and 2 queens. Okay. So again, I know my denominator is going to be 52. Choose 5. Okay. Kings, there's 4 of them. We're going to choose 3. Queens, there's 4 of them. We're going to choose 2. Okay, so on my calculator, let me do that again. No, it won't. Okay, that's okay. 4, math, choose 3, times, let's see, 4, choose 2, math, probability, choose 2, okay, divided by 52, math, choose 5, right, because we're taking a total of 5 of them. Enter math, fraction, does it work? Oh, it does not. Okay, so let's do this. Math, let's do the top part first. Choose 3 times 4 math, choose 2. Okay, so the top number is giving me 24. Okay, we can work with this. So let's go 52, choose 5. Massive number, right? 2589, 2598960. 2598960. Okay, so I know we can divide them both by 2. See if we can go by 4. Yes, we can. So we can divide them both by 4. When I divide the bottom number by 4, 64970. 64970. When I divide that one by 4, that's a 6. I know we can at least divide them both by 2 again, because they're both even. 324,870. 324,870. And that's 3. The only thing I'm going to try to do now, can I divide it by 3? Well, we could. Okay. So 108,290. 108,290. Let me just move this over a little bit. 108,290 all over 1. We actually just could have divided them, I guess, by 24 to begin with. I didn't even think about that. But anywho, there we go. Okay. All right. So let's finish up these last few problems for 11.9, okay? All right. So it says, a television game show has 5 doors, of which the contestant must pick 2. So 5, choose 2. Behind 2 of the doors are expensive cars, and behind the other 3 are consolation prizes. The contestant gets to keep the items behind the 2 doors she selects. Determine the probability that the contestant wins 19, no cars. Okay, so for number 19, we know our denominator is going to be 5, choose 2. 3 doors have consolation prizes. So we're going to say 3, choose 2. Okay, so this should work out on my calculator because my numbers are small enough. So let's go 3, choose 2. Divided by 5, 5, math, choose 2. And change it to a fraction. Should be 3/10, right? Yeah. So 3 out of 10. Okay. So 20. 20 says both cars. Well, we want both of them to be cars. So 2 of the doors have expensive cars. So 2, choose 2 out of 5, choose 2. Okay. So let me grab my calculator again. So 2, choose 2 divided by 5, choose 2. That should be 1/10, right? There we go. Okay, 1/10. Okay. 21. So guys, look at 21. It says at least 1 car. So remember, we did this before. The probability of at least one is equal to 1 minus the probability of none, which is what we did in 19. So look, if I'm going to go 1 minus 3 over 10, we can write that as 10 over 10 minus 3 over 10 gives me 7 over 10, right? 22. Exactly one car. So what does that mean? That means out of the ones that have cars, we're going to choose one. And out of the ones that don't have cars, we're going to choose one. Out of the 5 that we're choosing 2 from, right? So just sort of a quick little heads up here. I hope you're kind of noticing this, but if you take those numbers there and add them together, you get this one. And if you take that number there and that number there and add them together, you get that one, right? Okay, so let's do this on the calculator. Let me move this over here. So let's go math 2. Choose 1. 3. Math. Choose 1. Out of the 5 math, choose 2. Enter math fraction 3/5. There we go. Okay, so 3 out of 5. Excellent. Okay, so I think we're almost done. A couple more problems. Let's see, 2 more. So let's see if we can't figure this one out here. This one's going to take a little bit of time, guys. You can see it is a 4-part question. I think the hardest part in doing these is just the calculator work. It's kind of what slows me down. All right, so we have 12 new cereals. 3 of them are oat, 4 are wheat, 5 are rice. Okay, so if you just to double check, let's see. 3 and 4 is 7, and 5, yes, that gives us 12. Okay, and let's see. 4 new cereals will be produced. What's the probability that the 4 new cereals are? Okay, so again, first thing I know here is we have a total of 12, and we're going to choose 4. Okay, so let's do number 31. 12, choose 4. We want 2 oat and 2 rice. So there's 3 oat and there's 5 rice, and we want 2 of each. So it's going to be 3, choose 2, and 5, choose 2. Guys, I'm gonna save the calculator work here for you guys because I think we've done enough of these so you can kind of get the idea. So I'll just write it out so that you at least know how to set them up. Okay, let's do 32. So again, I know my denominator is going to be 12, choose 4. Okay, 1 is wheat. So how many? Let's do this real quick. Okay, how many wheat cereals do we have? We have 4 of them. So out of those 4, we want 1 of them to be wheat. Out of the 5 rice cereals, we want 3 of them to be rice. Okay. Let's take a look at number 33. 2 are oat, 1 is wheat, 1 is rice. Okay, so my denominator stays the same. 12, choose 4. Okay, 2 are oat. Well, we have 3 oat to begin with. So we're going to have 3, choose 2. 1 wheat, 4, choose 1. And 1 rice, 5, choose 1. And let's see, number 34. Number 34 says at least one of them is not an oat cereal. At least one of them is not an oat cereal. Hold on real quick, guys. Let's pause this. All right, so guys, I was looking at 34. It said at least one is an oat cereal. So remember, we want to find the probability of, at least one. It's going to be 1 minus the probability that none are oat. Okay. So let's find the probability that none are oat. No oats. Okay. My denominator is still 12, choose 5, right? Or 4, I'm sorry. We're picking 4 cereals. 12, choose 4. Okay. If we don't want any oats, I'm going to scratch out those 3. I'm only looking at the 4 wheat and the 5 rice. So 9, choose 4. Okay. So let's do this part here, see if we can get that part done. If I go like this, turn this thing on. What is 9? Math. Probability. Choose 4. Divided by 12. Math. Choose 4. Okay, well, let's see if it lets me do it as a fraction. Yes, 14 out of 55. Okay, so this here is going to be 14 out of 55. So now, when I want to do number 34, I'm going to take 1 minus 14 out of 55. So I can write that as 55 over 55 minus 14 out of 55. So I know my bottom part's going to stay 55. 55 minus 14 should be a total of 41, right? And there's my at least 1. Okay, and finally, the last problem here. It says of the 26 employees at Wegmans supermarket, 15 are cashiers, 11 are stock shelves. If 3 of the 26 are selected at random, determine all 3 are cashiers. So my denominator, 26, choose 3. We want all 3 of them to be cashiers. Well, we have a total of 15 cashiers. Choose 3. And again, I'll let you do the calculator work, okay? All right, so guys, that was 11.9. I know it's kind of a long section. Sorry, it takes me a little while with the calculator, but I want to make sure that you guys understand how to do the problems, okay? Y'all got questions? Let me know, okay? Hope y'all are doing well. Let's pause.